An insurer's annual weather-related loss, X, is a random variable with density function, given here. Calculate the difference between the 30th and 70th percentiles of X. So whenever you see the 30th and 70th percentiles, you're talking about accumulating individual probability values. Accumulating means that you will have to integrate. Okay, so obviously you're looking for a CDF function. It's a cumulative distribution function, that is, right? So we know that the CDF, cumulative distribution function of X, is going to be the probability that the random variable is less than or equal to a certain value y. Okay, which means, and this translates to the capital F of y. Okay, this is equivalent, and this is the integral from 200, that's the lowest value for the x, to the point y. Okay, to the point y, and you're going to integrate this function, obviously. 2.5 times 200 to the 2.5 divided by x to the 3.5 dx. Okay, so now what we're looking for, we need to find this upper limit value that will correspond to each of these percentiles, right? So this means the probability is going to be 3/10, like 30% will be the probability here. So what you got to do to find this upper value for individual cases, first you're going to take the first case. So 0.3 is going to be the capital F of the point A, right? So the upper limit will be A here in this case, and it's just a dummy letter. You can use any letter you want, right? So you're going to start from 200 all the way to A, and A is what we're going to need to find. Okay, so basically the 30th and 70th percentile is the point, is the upper limit here that will make sure that the cumulative probability will be 30%, and that's what we need to find. Okay, so we're going to have 2.5 times 200 to the 2.5 divided by x to the 3.5 dx. Okay, so then you know that this will be a constant, 2.5 times 200 to the 2.5 divided by what? And remember, you're going to have negative 2.5 from the power rule, right? Because this is x to the negative 3.5. If you were to put it in here, then you add 1, you would get negative 2.5, and also divide by negative 2.5, which is exactly what we did here. So as a result, x will be to the 2.5 in the denominator, right? Because the power rule, when it's negative 3.5 and it's upstairs, it will become x to the negative 2.5. X to the negative 2.5 upstairs in the antiderivative would be here, downstairs, but with a positive 2.5 and no minus sign. Okay, so then you evaluate this from 200 to A, and as a result, what are you going to get? You're going to get, let's see, so this cancels out, and this becomes negative 1, right? So we can put a negative sign, and then let's put 200 to the 2.5 like that. So what are we going to have? We're going to have first the 1 over A to the 2.5, right? Because we're plugging in the upper limit into the function, minus 1 over 200 to the 2.5. Okay, so now let's see what that's going to give us. Let's see, so minus 200 to the 2.5 over A to the 2.5 plus, and now when you, why is it a plus? Because there are two minuses here, so you get a plus, and 200 over 200 to the 2.5 divided by the 200 to the 2.5 is 1, right? So it's just 1. So now that is set equal to 0.3, as you remember, right? Because that's what we did. So you solve for A to the 2.5 algebraically. So you would have negative 200 to the 2.5 divided by a to the 2.5 is equal to what? Is equal to negative 0.7. Now we can cancel out the negatives because you can multiply both sides by negative, you get rid of them, and they become positive. So now this is equivalent to saying that a to the 2.5 is equal to 200 to the 2.5 divided by 0.7. So that means a is equal to what? A is equal to this quotient, 200 to the 2.5 divided by 0.7 raised to 1 over 2.5, right? Because to solve for a, you would need to take the power of a power, take this to the power of 1 over 2.5, then you will have a to the first power, right? But whatever you do to one side must be done to another, so that's why we did the same thing to this, right? We raised this to the power of 1 over 2.5 to solve for a. So now if you do this in your calculator, you have to round it to the nearest tenth. So dividing that and then taking, you will have 230.7. Now before moving on, I want you to really think about what you just found. Basically what this means in words is that there's a 30% probability or 30% chance, however you want to say it, that the insurer's annual weather-related loss will be 230.7. Okay, whatever the units is. It's not given the units, thousands of dollars, you know, or anything else. But this is what it means. Okay, so now let's go on to part B to find the 70th percentile. Okay, so let's do the same thing. So we don't have to do all this work. We can just substitute the numbers for 0.7. So what are we going to do here? We're going to just substitute, let's just copy this part. So negative 200 to the 2.5 divided by a to the 2.5 plus 1 is equal to 0.7. You see, I'm just substituting 0.3 with 0.7 because it's the same exact integral, right? So then this thing, 200 to the 2.5 divided by a to the 2.5 would be equal to 0.3 now, right? Because you subtract 1, you get negative, two negatives get cancelled out, you get 0.3, the positive, right? So now, well, except this is not a anymore, this is b now, right? So we need to correct that because that's going to be a different percentile, right? So it's going to be b raised to the 2.5 power. So now as a result, what does b equal? B is equal to the quotient of 200 to the 2.5 divided by 0.3 this time, and not 0.7, right? So 0.3, and that will be raised to the same power, 1 over 2.5, right? Because to solve for b, we need to take this to the power of 1 over 2.5 to have the power of b equal to 1, right? And that's the same thing we're doing to the second side, to this side, right? So then b is equal to what? Let's see. In the calculator, this is going to be 323.7. So now the question asks us to calculate the difference between these two percentiles, right? So b minus a, because b is greater than the a, right? Difference always means that it's going to be a positive result and not negative. And in the answer choices, they will give you positive numbers. 5 choices, all will be positive. So b minus a is going to be this minus this, right? And that's exactly 93, and that will be in the answer choice in the actual exam that you will, encounter. Thank you so much for watching. Hope this was helpful. See you in the next video.